Hello guys, we got a problem here which reads 3 cables are used to tether a balloon as shown. Determine the vertical force P exerted by the balloon at A, knowing that the tension in cable AD is 481 Newton. Actually, in this problem, the 3 cables, we have got 3 cables A, B, AC and AD supporting the balloon. So we are told to find the force P exerted by the balloon. This force is actually in y-axis because it is the force exerted by the balloon to counteract the effects of the 3 cables. So the 3 cables are AB, AC, and AD. Now, this system is in equilibrium. Remember that if a system is in equilibrium in mechanics, it's not moving, which means it is at rest, or when it is moving with constant or uniform velocity or speed. Now, the first step in solving the question, we are going to write the direction vectors along the cables and find the unit vectors. So AB, the direction vector of AB, so when we are moving from A to B, how much in X direction do we move, or in Y and Z direction? So when I start from A to B, I'm going to move 4.20 meters away from X, which means that is negative 4.20 I, that is in X direction. And then I'm going to move down, which means we are moving down the y-axis, and we are moving negative 5.60 meters, which means down, which means 5.60 J. And then in Z direction, we are not moving, which means from A to B, we don't move in Z direction. So this is the direction vector AB. So let's find the unit vector along AB. So the unit vector along AB is equal to vector AB divided by the magnitude of AB. How do we find the magnitude of AB? AB magnitude, this is simple. We just have to take the take the square root of the square of the sum of the squares of the components of the vector. So in this case, we're gonna take negative 4.2 squared plus negative 5.6 squared, and the magnitude is always positive. Which means here, because we know that when a negative number is squared, it means that we're gonna have a positive number. So here we can just put positive numbers, so it doesn't matter. So here we are having, when we evaluate this, let me use my calculator. So 4.2 5.60. So here it's gonna be the square root of 49, which is equal to 7. So this is the magnitude of a vector, of the direction vector AB. So here it's gonna be negative 4.20 20 I minus 5.60 J over 7. So I found the magnitude is 7. So to express cable AB in a vector form, we have to multiply the direction vector by the tension, the cable. So we know that TAB, which means the tension in a cable AB as a vector, is equal to the magnitude of TAB, okay, magnitude of TAB multiplied by direction vector, which means it have to be multiplied by direction vector AB. So in this case, TAB is not known, so this is not known, but we know the direction vector, which is this one, so we're gonna just write it the way it is. So multiply by, means let's just move D7 here, then others gonna multiply like this. Yeah, so in this case we have expressed the tension in a cable T in a cable AB in a vector form. So let's go on and do with other cables. So we have got a cable let's find direction vector AD. So if we follow the same procedure, we are moving from A to D. So we are moving from A to D. So basically we don't move, which means the x component of the direction vector of AD is 0, because we are not moving anywhere in x, okay, because D lies exactly on Z axis. So here we're gonna move down the y axis, which means we're gonna move negative 5.6 J, and then we're gonna move away from the Z axis, which means that's gonna be negative 3.30 K. Yeah, here's there is a very important point worth mentioning. That is when you have, because most students get confused to whether which side is positive and which side is negative. When you have got a coordinates here, y, and here I've got x and z, this side here, okay, toward x or toward z or toward y, they are positive. Anywhere away from x, which means this way, or away from y, this way, or away from z, this way, they're negative. So that's very important to keep in mind. Yeah, now if we express TAD, that is the tension in a cable AD in a vector form, we're gonna get this expression. So we're going to have this expression. So I have just simplified them. So as we know from the equation, TAD is equal to 481 Newton. So we can just go on and simplify it. The same with TAC, we have this expression. Now, AC, how did we find AC? Now, AC, we are moving from A to C. That is, which means C, we're going to have to move in X direction, which means we're going to move some distance in X direction, which is 2, which is actually 2.4. And then we move in Y direction, which means we go down, which means negative 5.6. And then we move in Z direction, which is 4.20. So as we can see. Now, the remaining step is to explace all the components. We know that when a system is in equilibrium, it means that the summation of all the forces are 0, which means the summation in the X direction, in Y direction, and in Z direction is equal to 0. So this means that the summation of F is equal to 0, which means that the summation of F in X direction, in Y direction, or in Z direction is equal to 0. So everything here is equal to 0, which is actually this one that is in Y direction. It has to be negative. TAC, which was we took in J direction, which means we took 5.6, negative 5.6 divided by 7.4 times TAC. So here I have collected all the I components or X components together, and then I equalize them to 0. I did the same with J and K components. Remember that on J components we have got P, which is the force of balloon acting upon A, which means, as I said before, that the P is acting to counteract the effects of the 3 tensions in a cable. So we have we can use the third equation to find the value of TAC, which means the tensions, the magnitude of TAC. So using the third equation, we know that TAC gonna be equal to 244.2 divided by 0.57, and this gonna bring us divided by 0.57. Me calculate, I got 428.42 newtons. That's the magnitude of TAC. Well, now using the equation 3, we have found that TAC is equal to 428.42 newtons. So we can use the equation 1 to find the value of TAB. So using 1, find the value of TAC, AB. So we're gonna have TAB is equal to 0.32 TAC, which means 428.42 divided by 0.6. So using my calculator, this gives me 428.42 divided by 0.6. This gives me 2 428.49 newtons. So that is the magnitude of the tension in cable AB. Now, what is the magnitude of P? To find the magnitude of P, we're gonna use the equation 2. So using 2, we're gonna solve for the value of P, and that's where the question is. So we know AB, we know TAB, we know TAC. So solving the value of P would be very simple. So we know that negative 0.8 TAB we have found is 228.49 minus 414.4 minus 0.76 TAC, that is 428.42, then plus P is equal to 0. So basically P is going to be equal to 0.8 multiplied by 228.49. So P is gonna be equal to 922.79. Is it so? That is the last answer, which means the balloon is exerting the force of 922.79 newtons. So that is the force. That's the last answer. That's the answer. So when you are solving these kinds of equations, in the middle of equations, in the middle of solving, it's better that you keep a lot of decimal places, because this would make your answer to be more accurate. Here I have rounded the answers, all my calculations to 2 decimal places just for simplifications. But when you're solving, you're encouraged actually to round at least to 3 decimal places, or the maximum to 4 decimal places. Yeah, that actually will help you to get the answers which are very accurate.